Hello, and welcome to Math Matters. I'm Mrs. Halpin, and today we're going to learn how to find the area of a circle. As mathematicians, it's really important to know how and why certain things work with mathematics. Today, we're going to explore how and why the formula for finding the area of a circle works. For this lesson, you will need paper and a pencil or something else to write with. A calculator with pi would also be helpful for this lesson, but it's not necessary at all, and we're actually going to dive into the calculator a little bit more next time. We're going to pause while you take a minute to gather those materials. Now that you have your materials, let's get started. So now we're going to try a routine called Would You Rather. You are sharing a pizza with 3 friends. Would you rather eat pizza A or pizza B? And why? I'll give you a few seconds to think about that. If you're not feeling hungry, you might be thinking you would share pizza B with 3 friends because it's smaller and you might just want a snack. You also might prefer pizza B if you really like pepperoni pizza. However, if you are feeling really hungry, you might want to share pizza A. As you can see, pizza A is larger. It has more space. It has a larger area. Therefore, each slice of pizza you would eat would be larger on pizza A than pizza B. Let's explore this idea of area a little bit more when thinking about circles. We have discussed the area as the amount of space inside of a two-dimensional object. I can also describe the area as the number of square units it takes to completely cover a shape. So now we can see that the area of the pizza can be measured in square units. When we found the area of rectangles, we counted the number of square units that completely covers a shape. Can we do that with circles? What might make this challenging? I'll give you a few seconds to think about that. What might make that challenging? You might have noticed that this circle is curved. It does not have straight side lengths, and it's hard to count those partially covered squares. We could estimate the area of the circle, but this strategy would not work to find the exact answer. Let's just take a moment to think about how we would estimate the area of this pizza. So we're thinking about pizza A, and we can count 16 whole square units, and then we can estimate by combining parts of square units. So again, when I'm combining these parts, it's not that it makes one whole square unit, it's that we're estimating. So our estimate for the area of a circle is 24 units squared. This is another circle. We could count the square units and try to estimate the area of the circle. It might be really challenging to do this because this circle is much larger and it has many more square units than the pizzas we just looked at, so it would take a really long time. Let's see how we can use the parts of a circle and the relationships they have to each other to find the area. talk about the parts of this circle. A line segment that passes through the center of the circle is called the diameter. A line segment that starts in the center of the circle and extends to the edge is called a radius. The radius is always half as long as the diameter. We could also describe this relationship by saying the diameter is always twice as long as the radius. This picture might remind you of a coordinate plane that is split into 4 equal sections. We call one of these sections a quadrant. There are 4 quadrants on this picture. How might you use the radius of the circle to determine the area of one of the 4 quadrants on the grid? Well, let's think about it. So here's the radius. And how might I use that to determine the area of this quadrant outlined in red? I'm going to give you a few seconds to think about that. You might be noticing that the quadrant is a square. All sides are the same length. To find the area of the square, I would multiply 2 side lengths. Since each side length is 10, I could multiply 10 times 10 to find the area. I could also find the area by taking the side length and squaring it, or 10 squared. So I can see that the area of this square or quadrant is 100 units squared. The side length of this square is also the radius of the circle. So I could represent the area as area equals radius squared. I wonder how we could estimate the area of the circle using the information we just discovered about the area of one of the quadrants. I'm thinking about some questions I could ask myself to help me think about this idea. How much of the 4 quadrants does the circle cover? I'll give you a little time to think about this. You might be thinking that the circle covers most, but not all of the quadrants. So if the area of one quadrant is r squared, what is a good estimate for the area of the circle? You might be thinking, well, I could take the area of one quadrant and multiply it by 4, since there are 4 quadrants. If I took the area of one quadrant, which is 100 units squared, and multiplied it by 4, I would have 400 units squared. But I know the area of the circle is less than the area of all 4 quadrants, so it would have to be less than 400 units squared. If we had a little bit more time, we could take the pieces that are not part of the circle and subtract it from the entire square to get a closer estimate. But I think what's important here is that we recognize as part of our estimate that the area is going to be less than 400 units squared. I'm going to cut out these quadrants and see how many or what portion of the quadrants I can physically fit into the circle. I separated each quadrant by using a different color. Imagine me cutting out each quadrant. Let's see how the purple quadrant can fit into the circle. I can use the larger part of the radius square or quadrant to cover the top left quarter of the circle. I can use the smaller piece to begin covering the bottom right quarter of the circle. Now the area of the purple quadrant is covering the circle. Now we can do the same with the yellow quadrant. I can take the larger piece and cover the right quarter of the circle on the top. Notice that this time I had to break up that corner into smaller pieces so those little yellow pieces would fit. And keep in mind, I was cutting out these pieces, so it's not completely accurate, but it's pretty close. I'm still using all of the yellow quadrant. I'm just rearranging it so that it fits inside of the circle. Next, I can take another quadrant, the blue quadrant, to see how I can fit it inside of the circle. I can fill the bottom left fourth of the circle. I can also take those blue pieces and move them in to fill more of that bottom right quarter of the circle. I see that I still have some white space left. I have not completely covered the circle yet, but I'm getting close. Now I'm going to take a very small portion of the green quadrant to cover the remaining white space. I have used 3 whole quadrants to cover the circle, and I've used just a little bit of the last quadrant, the green quadrant, to cover the circle. Specifically, I have used about 14 green squares to cover the remaining space. I have used approximately 3 14/100 of the quadrants to completely cover the circle. Let's see how this process connects to the formula for finding the area of a circle. We first found the area of one quadrant by doing radius squared. Next, we found that it would take 3 quadrants and a little more to completely cover the circle. For this activity, the 3 and a little more is an estimate for pi. So we can multiply pi by the radius squared, or the area of one quadrant, to find the area of any circle. Let's find the exact area of this circle. We know the radius is 10 units, so I can plug this number into my formula. We multiply pi by 10 squared, which is 100, and I'm going to approximate pi by using 3.14. 3 14/100 times 100 is 314, so my area is approximately 314 units squared. When we reflect back on our estimate, this makes a lot of sense. We knew the area had to be smaller than 400 square units because the area of the 4 quadrants was about 400 units, and it had to be less than that. So let's revisit pizza A, the same pizza that we were looking at earlier. So we estimated that the area of this pizza is 24 units squared. Now let's determine the exact area using the formula we just discovered. The formula for finding the area of a circle is pi times radius squared. The radius of my circle is 3 units. So I can find the area by multiplying pi times 3 squared. Well, 3 squared is 9, so now I have pi times 9. I'm going to use 3 14/100 or 3.14 as an approximate value for pi because 3.14 is very close to the value of pi. I can now see that my area is 28 26/100 units squared. Next time, you will actually learn how to use and how to practice with the calculator to find the area of a circle. Today is just an introduction so that we understand where the formula comes from. So when we think about our answer of 28 26/100 and compare it to our estimate of 24 units squared, it's pretty close. It makes sense. And as mathematicians, we're constantly trying to find an estimate to know, does our answer make sense? Is it reasonable? So in this case, yes, my estimate of 24 units squared is reasonable because it's fairly close to 28 and 26 units squared. We see circles so often in our daily lives. You might notice the circular pattern of a tree trunk or even neighborhood homes arranged in a circular formation. Where else might you see circles in the world around you? In today's episode of Math Matters, we use the relationships within a circle to discover the formula for finding the area of a circle. It's important that mathematicians know how and why formulas work. Next time, we will find and calculate both the area and circumference of circles using real-world scenarios. I'm Mrs. Halpin. I hope you have a great day and keep on counting.